Leetcode question number 793, preimage size of factorial zeros function. So as it is clear from the definition, we just have to find out the total numbers such that the x factorial contain k zeros. For example, 3 factorial equal to 6, which do not contain any zero, and 11 factorial contain 2 zeros. So we have to count the total number of the x for which it holds, such that function of x equal to k. So for example, if k equal to 2 or k equal to 1, 0 factorial will be equal to 1, 1 factorial will be equal to 1, 2 factorial will be equal to 2, 3 will be equal to 6, then 24, then 120, then 120 for the 5 factorial, then it will be 720, so on until 9 factorial. So here from 5 to 9, it contains 1 0. So for k equal to 1, answer will be 5, which is 5, 6, 7, 8 and 9. So one observation is that answer can only be either 5 or 0. Because if there do not exist any number such that it has k leading zeros, so answer will be 0, else answer will be 5. So one way to solve this is a linear method in which we can iterate from I equal to 0 to I is some larger number until k will be equal to 0. For example, we will keep counting the number of the zeros at the end, and we will check if it is smaller than k, then we will increment our number, and if it is larger than k, then we will break out from the loop, and if it is equal to k, then we will increment our counter, and at the end of this we will return our counter. But as the k can vary from 0 to 10 to the power 9, it will give the TLE. And one another important observation is that number of the 5 will always dominate the total number of the 2. For example, if we take number until 5 factorial, so total number of the 2 will be equal to 2, and in the 4 it will be equal to 2. So total number of the 2 will be equal to 3, and total number of the 5 will be equal to 1. So total number of the 2 will always be greater than the total number of the 5 in x factorial. We can all say that 5 will be smaller than equal to the total number of the 2. And because 10 can be represented as the power of the 2 into power of the 5, and a will be always greater than equal to b. So we only need to count the total number of the b. For example, if the total number of the b is let's say 10, then there will be 10 zeros at the end of the factorial. If the total number of the b is 5, there will be 5 zeros at the end of the factorial. So we only need to count the total number of the 5. And so now our problem has been reduced to count the total number of the 5. We can say that we have to count the total number of the 5 such that the given x factorial modulus 5 raised to power k will be equal to 0. And we have to find count the number of the x. So we can solve this problem using the binary search, in which we will take a mid element, and we will check whether we can have the mid number of the 5 or not. If we can have the mid number of the 5, then we will increment low to mid plus 1. Else, if the mid element contain more than k5, then we will decrement the high to the mid minus 1, and we will continue this until we find a number which contain the k number of the 5. And at the end of this, if we find this, then we will return 5. Otherwise, we will return 0, because answer can only be 5 or 0. So to solve this, we can take a long low equal to 0 because k can be equal to 0 and high will be equal to 5e9. We can take 5e9. So while low is smaller than equal to the high, we can take a mid element will equal to low plus high divisible by 2, and we can create a check function if in which we will pass mid and k, which mean we can have mid number of the 5 which is smaller than k. Then we will increment our update our low with mid plus 1, and we will update our answer equal to mid, and here we can also declare our answer equal to -1. Else we will update our high equal to mid -1, and here we can create a bool function, check function, which will take the mid and k. So we can take a counter, initial counter equal to 0. So while mid is greater than 0, mid c plus equal to mid divisible by 5, and c then mid will be divisible by 5, and we will keep doing this. At the end of this we can check if our count is smaller than equal to k. Okay, now we have our temporary answer, but we also have to check whether the mid contain k number of the element 5 or not. For example, if mid answer do not contain the k number of the 5, then we will return 0. So to check this, we can create a counter. So while answer is greater than 0, we will increment our counter with the answer divisible by 5, and we will divide answer by the 5, and at the end of this we will check if our answer equal to -1, which mean we do not found anything, we will return 0, or else we can simply return 5 into. So if our answer it will be counter. So if our counter equal to k, which mean we find the numbers, we will multiply it by the 1, else we will multiply it by the 0. So we can submit it. Thank you.